Hi, in this video I will be showing you problem number 40 of chapter 14 section 8, which is a practice exam question. Use Lagrange multipliers to find the dimensions of a rectangular box with largest volume if the total surface area is given as 400 centimeters square. So we have two functions here. One is a volume function, which we call it f of x, y, z, where x represents the length, y represents the width, and z represents the height, which is x, y, z. Where x represents the length of the box, y represents the width of the box, and z represents the height of the box. So as the surface area here is given in terms of centimeter squares, we'll assume that each dimension is measured in terms of centimeter. Now we will write down the surface area equation. So surface area is the constraint here. That is the constraint function. I'll call that as g of xyz, which is the area of the base and the area of the sides and area of the top. So it will be 2 times the area of the base and the area of the top would be the same. That will be 2 times xy. The sides, you will have y times z, but will have 2 sides, and then x times z will have 2 sides. So there are 6 sides in total. The total surface area is going to be 400 centimeters square. So if we divide throughout by 2, g of xyz would become xy plus yz plus xz equal to 200. Call it equation 2. So we are asked to use Lagrange multipliers. So gradient f equal to lambda times gradient g. That will give us partial derivative of f with respect to x, partial derivative with respect to y, partial derivative with respect to z for f equal to lambda times partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z of the g function. This will be equal to fx. So if you differentiate with respect to x of the y function, that will be yz. Then this will be xz, fy. Fz would be xy equal to lambda times gx. So this is our g function. So you're differentiating with respect to x. That will be y plus z. Gy would be with respect to y. So x plus z. With respect to z, that will be x plus y. Now we are going to equate the corresponding components. Yz equal to lambda times y plus z. Then xz would be lambda times x plus z. Then xy would be lambda times x plus y. We'll call it equation 1, equation 2, and equation 3. Now we have 3 unknowns and 3 variables. Lambda yz and then lambda y and z in the first equation. In the second equation we have lambda xz. In the third equation we have lambda xy. So there are many ways of solving these equations. Now we will try to do 1 minus 2, equation 1 minus equation 2. That will give us on the left hand side yz minus xz equal to lambda times subtract which is y plus z minus x plus z. So this would mean if you take the z out, z times y minus x equal to lambda times, here z would get cancelled out if you distribute the minus. So you'll be left with y minus x. If you move everything to one side, z times y minus x minus lambda times y minus x equal to 0. Here the common factor is y minus x. So if you remove y minus x, you'll be left with z minus lambda equal to 0. This means either x equal to y or lambda equal to z. Now, if lambda was equal to z by any chance, then we'll eliminate that possibility, substituting this into equation 1. So, substituting lambda equal to z in equation 1, we get yz equal to z times y plus z. We are substituting lambda equal to z. So this lambda here gets replaced by z. So this will mean yz equal to yz plus z square if you distribute the z. So yz cancel out, you get z square equal to 0 or z equal to 0. Z cannot be equal to 0 because that is height of the rectangle, the height of the box. So not equal to 0. So lambda equal to z is not possible. So the only option is here x equals y. So we got this to this relation when we considered subtracting 2 from 1, equation 2 from equation 1. So now we'll call it say A. When we'll do the same computation, we will consider equation 2 minus equation 3. So that will give us xz equal to lambda times x plus z. We are subtracting equation 3 from equation 1. So it is left hand side, if you subtract, it will be xz minus xy. Right hand side will be lambda times x plus z minus lambda times x plus y. So if you common factor the x out, x times z minus y equal to lambda times, here x will get cancelled out, it is again z minus y. So this will mean if you move all to one side, so x times z minus y minus lambda times z minus y equal to 0 by moving everything to one side. So this will mean z minus y times, which is common here, times x minus lambda equal to 0. This would mean either y equal to z or lambda equal to x. As we did before, like lambda equal to z was eliminated. So when we substitute lambda equal to x into equation 2, if we substitute lambda equal to x in equation 2, we will get a result x square equal to 0. That would mean x equal to 0, which is not possible. So we are going to eliminate that possibility. And then by considering equation 3 minus equation 1, this would give us x equal to y equal to z equal to x condition. So x equal to y equal to z. So which shows that the length, width and the height are all equal in a rectangular box, which makes it into a cube. And also we have to find out the dimensions. So we will use the constraint function, which we have not used. So constraint function is, in this problem, xy plus yz plus xz equal to 200. That is the constraint one. So xy plus yz plus ex equal to 200. Now we have x equal to y equal to z. So we have x times y. Y can be replaced by x. So that would give us x square. This would also give x square. This also gives x square equal to 200. Or 3x square equal to 200. That would give x square equal to 200 over 3. Or x equal to 2 square root of 2 times square root of 100, which is 10, divided by square root of 3. And then if we multiply both sides by root of 2 times root of 2, this would give us 10 times 2 over square root of 6, which is 20 over square root of 6. So x equal to y equal to z, each one equal to 20 over root 6 centimeter. In other words, length and the width and the height are 20 over root of 6 centimeter each. It tells enter the dimensions in centimeter as a comma separated list. So it will be 20 over root of 6 centimeter, comma 20 over root of 6 centimeter, comma 20 over root of 6 centimeter. Those are the dimensions. I hope that this video helps.